All right, the slant height. Remember that the slant height is this guy right here. It's the height of the cone, but in a slanty sort of way. So the slant height. This is now where my first thought of like, oh, Pythagorean theorem. I'm gonna be like, okay, here is where I apply the Pythagorean theorem because now that I know that my radius is 3, I can say, that's just a right triangle, and I have only one variable now. You can do the Pythagorean theorem, and you get that L is equal to 5. Remember, 3, 4, 5 right triangles. This is where remembering 3, 4, 5 would be helpful, that you don't have to do Pythagorean theorem, and this 2-mark question could be quick, 2 seconds, and then you now get extra time on another thing. So remembering things like 3, 4, 5 right triangles could be a great time saver for you at some point. Now it says find the total surface area of the ice cream. We are going to, let's write out our idea of the surface area. So surface area total. It's going to be the surface area of the cone plus half of the surface area of a sphere. So when we're talking about the surface area of the cone, we only want the slant height of the cone, right? So when we have a cone, this guy is the slant height. And then you've got normally like a circle on top of the cone. We will not be including the circle of this on top of this guy because that's not on the surface, right? That circle is in between the two shapes that composite together. So just realize what's on the outside of the shape, and that would be the surface area. So the outside of the shape is half of a sphere and then the slant height of a cone. So I really am only looking at the slant height. Again, this can be found in your formula packet. The slant height of your cone is just pi r L. And then half of the surface area of a sphere, the surface area of a sphere is 4 pi r squared, also found in your formula packet. I can simplify this down. And then I need to find my ingredients. So I've got the main idea of what I need to do. I need to say, the radius is just 3, and L, our slant height, is just 4. Oh, sorry. Notice that we had to use 3 in order to answer this question below. We had to use C in order to answer this question below. So just remember your follow-through marks on tests, right? That whatever answer you get here, as long as you use it correctly down here, you get all the points that you need for part D. You would just only lose points in part C. Now I get to plug things in. And go ahead and tell me what that comes out to be. To 3 significant figures, we get 104 meters squared. All right. Go ahead and see if you can try and answer E on your own. This is a classic follow-through problem in an IB exam of the next thing that you would answer after you've gotten this one. The ice cream is to be made from a lightweight polymer weighing 1.2 kilograms per meters squared. Calculate the total weight of the ice cream. So when we give a ratio of it's 1.23 kilograms per meters squared, you can think of it as a separate thing, that there's 1.23 kilograms for every 1 meter squared. Now, if you said, okay, then what would be 2 meters squared? Well, it would be 2.46, right? Double of this. What would be 5 meters squared? Well, it's 5 times this. Now that ratio should stay the same, right? The ice cream, it weighs this much, that weight stays the same. It is a constant ratio. So if I said, well, I've got my meters squared, the surface area, which accounts for the material that's going to be making this ice cream, 104 meters squared is the surface area that I need to account for. And notice the relationship between the units, meters squared, meters squared. So that would be another hint in the problem for you to be like, okay, I'm using my surface area here. And then you don't know what the weight is. So that would be X kilograms. So when you're given rates like this, whether it's speed, whether it's a weight, whether it's anything that comes in a ratio of unit over unit, if we want to solve for the kilograms, the weight, right, and we want to have it in regards to meters squared, it's starting to tell you the relationship between what we're trying to create here. And if it's a ratio, then it just should be equal to the ratio of whatever you have. So I've got 104 meters squared. I just don't know what the weight of that is. Cross multiply and solve. It's pretty straightforward because 1 times x would just be x equals, and then 1.23 times 104 to 3 significant figures is about 128 kilograms. All right. So this is a pretty straightforward classic IB level problem of the type of problems, the way that the problem would be structured. And the difficulty level is not very difficult. So you would probably expect in the upcoming test to have something that looks like that, but might be just slightly more difficult. Okay, this guy, however, is really difficult because there's a lot going on, and also there's a few things that we haven't talked about in this class. It's technically considered prior knowledge, but we will definitely spend time talking a little bit more about this in a couple units. This thing is 3D coordinate geometry. So we're talking about three-dimensional planes and 3D graphing. And so notice that we've been given a lot of information about the Sydney, Australia, which is the second tallest observation tower in the Southern Hemisphere. And we're going to find the volume of this tower. This would be a classic IA prompt of like, okay, you have something that you're interested in finding more out about. And so if you wanted to find out the volume of this thing to be able to break down a structure into mathematical concepts and calculate things with it, that would be an interesting geometry focused IA. So we want to find the volume of this composite figure. This composite figure is an additive sort of composite figure in the fact that we've got 4 cylinders all brought together to make it in total, right? We're not like taking something out and we're talking about something that's been left over after we've taken it out. So I'm going to write down the general idea of the volume. And I know that the general idea, the volume total, is going to be all 4 of these cylinders added up. I'm going to number them. So it's going to be the volume of cylinder 1 plus the volume of cylinder 2, 3, and 4. So the general idea, and I know it seems silly, but it's really crucial for starting a problem of a composite figure to keep track of everything. Now, all of these volumes are going to be the volumes of a cylinder because they're all just different sized cylinders. And it's pi r squared h. That's your volume formula for a cylinder. So for all of these guys, I need to have a radius and I need to have the height. Okay, let's start off with cylinder number 1. Cylinder number 1, we want to find the radius. In a coordinate plane, when you're talking about 3D geometry, you have 3 coordinates. It's still in alphabetical order. So where it used to be just x, y, it's now x, y, z. X is this way, y is this way, and z is this way. So that means that we went 3, 0, 0. We went 3 out, 0 side to side, and 0 up. So we are right here at 3. This will tell us the information that we need. The radius, if we think about it, this circle, the radius starts from the center and comes out. And since we haven't moved off of that axis, we can think about it in this way. Since we're just right here, that is the radius. That coordinate of, that coordinate of 3 is the radius. And so this is one of the easier cylinders to figure some things out with because we have the radius from the beginning. Notice these guys later on aren't on an axis, and so we'll have to do some calculations on finding the radius. Okay, so the radius is 3. The height. So we start here at 0, and we are talking about the z value, right? How tall it is. So we're looking at the last coordinate. Going from the bottom of the cylinder to the top of the cylinder, this point right here is aligned with that plane. And so which of these numbers is going to give us the height of the cylinder.